Voltage, current and resistance are related by Ohm's law. So we can explore these things using ExpEYES. So we'll be using this schematic. Here you see two resistances and they are connected in series, and one end we are applying a voltage from PB1, and the midpoint we are measuring with A1, and this end is grounded. Here we cannot measure current directly because ExpEYES doesn't have an ammeter. But suppose if you know the value of R2, say if R2 is 1 kilo ohm, and if you measure 1 volt on A1, that means current is 1 milliampere. So we'll use this relationship and study the current through R1 and the voltage drop across R1. So let us make these connections. R2 will be 1K and R1 we will use some other value. So what we are going to do is from ground to A1 is our $1K, and now we need another connection from PV1. So we will put a clip here and just so this is our connection. So we have the programmable voltage here, and it is coming through a resistor to A1, and then from A1 you have another resistance going to ground. So let us see what is the value at A1. A1 is showing some value, so we have to just see what is the value at. So let us set some value. Say we set 3 volts at PV1 and A1 is something like 0.944, and if we set say 4 volts, we are finding that A1 is 1.26. So from this we can find out the current. See, A1 is 1.26 volts and the resistance is 1K. That means the current is 1.26 milliampere, and the same current flows through R1. So how do we find out the value of R1? We know this voltage, that is 4 volts, and this is 1.26. So 4 by 1.26 is the voltage drop across this, and that would be how much? That is for say 2.7, something like 2.75, and that divided by the current. So that will give the value of R1. And if you want to plot this voltage current relationship across R1, we can choose from say electrical plot IV curve. So again the same connections, and we can just plot the graph. See, we are changing PV1 from -5 to 5 volts, and resistance from A1 to ground is entered here, that is 1 kilo ohm. So it plotted the graph, and the slope of this graph, dV by di, is the resistance, right, V by I. So that is roughly 2.2K, right, 2179 ohms. So now we can try another resistance and see how the graph looks like. So let us change the resistor. We will put another resistance having a different value. and we will come back and start again. So it's having a different slope, so the current variation is actually less, and that is roughly 10 kilo. So you see how the voltage and current are changing. So it's a straight line, that means it's a linear relationship, right? Current is proportional to voltage. Now we can try one more thing. We can, instead of the resistance, let us put a diode and see what happens. We will put a diode here and try to plot the voltage versus current. You can see that the current is 0. See, voltage is changing from -5, and when it reaches around say 0.6 volt, the current started increasing. So these two are linear, and this is not a straight line, this is non-linear. So you can say that diode is a non-linear element. That means current and voltage are not proportional. So these are the ways you can explore the relationship between voltage and current using ExpEYES.